Okay, here we have a question about the force exerted on an eye due to glaucoma. So we have normally there's 24 millimeters. The pressure is 24 millimeters of mercury, um, also known as 24 torr, right? So millimeters of mercury is sometimes referred to as torr. Um, and it maintains the shape of the eye. And if this pressure increases to 50 torr, 50 millimeters of mercury, then we have glaucoma. So what's the increase of force on the walls of the eye if the pressure increases by 26 torr here? And it says that we can accurately model the eye as a sphere 2.5 centimeters in diameter, right? So, kind of first off, we have just kind of writing out some of our conversions with pressure. 1 atmosphere of pressure is known as, this is the same as 760 torr, or 760 millimeters of mercury, millimeters Hg. Hg is mercury, right? And this is also equal to 1.013 times 10 to the fifth pascals, right? And pascals, the units of pascals here, and this is typically what you use in physics. I think torr is more in the medical community. Atmospheres or pascals or physics. This is newtons per square meter. That's what a pascal is, right? And so we're given here, metric units for the diameter of the eye, and we want to know in newtons, so we'll need to use pascals, right? So I guess the first thing to talk about is, what is the increase in pressure measured in pascals? So our increase in pressure, call this delta P, this is 50 minus 24. It's 26 torr, right? And so that's going to be, I'll multiply this by, well, there's 760 torr in 101,300 pascals. So multiply this by 1.013 times 10 to the fifth pascals divided by 760 torr, right? And then the torr cancel, and we have pascals. And so the increase in pressure comes out to, this is about 3,465 and a half pascals, okay? And all right, so there's the increase in pressure in pascals, and we want the force though, right? Not the pressure, but we want to know actually how much force is being exerted on the eye, how much additional force. And we know that pressure is equal to force over area, right? And so obviously we can say that change in pressure would be equal to the change in force over the area, right? So the increase in pressure would be the increase in force divided by the area. So we can say then, just doing some algebra, that the change in force is going to be the change in pressure times the area, right? In which we have the change in pressure is this. We just need the area, and of course, if this is in pascals and newtons per meter squared, then we need the area in meters squared, right? So the area, the surface area of a sphere, and I would give this to you if you need this in a quiz or exam or something, but the surface area of a square of a sphere is 4 pi r squared. So this would be 4 pi, and our radius, I think this is a 2.5 centimeter diameter, so 1.25 centimeter radius. But then we'll need to move the decimal place over twice to get our, meters, right? So, so this is going to be 0.12. Oops, sorry. Gotta move it over twice. 1.25, 0.0125 meters, right? Squared. So there's our there's our area. And so, this change in force is going to be this change in pressure, 3,465 and a half. 65 and a half newtons per meter squared times 4 pi times 0.0125 meters squared. You see that we have just newtons left, and you can run through these calculations here, but the change in force is about 6.8 newtons. So about an extra 7 newtons there to get that blockage.